Why is your Databricks job slow? Most of the time, the problem is not just one line of code. It is a combination of how your data is stored, how Spark moves data, how your joins work, how memory is used, and how your cluster is configured. In this video, we will quickly explore 7 common problems every data engineer should understand. Too many small files, bad partitioning, expensive shuffle, data skew, slow joins, disk spill, and wrong cluster configuration. Think of this as your first diagnostic map. Before you start changing random settings, you need to understand where the real bottleneck is. When a Databricks job is slow, start with the symptoms. Maybe the stages take too long. Maybe the cost is too high. Maybe dashboards are slow, tasks keep retrying, or the job finishes late. But symptoms are only the surface. Behind them, you may find small files, bad partitioning, shuffle, skew, slow joins, disk spill, or cluster issues. The first place to investigate is the Spark UI. Look at stage duration, shuffle read and write, spill metrics, and executor balance. Good tuning starts with observation, not guessing. The first common problem is too many small files. Imagine Spark trying to read thousands of tiny files instead of a smaller number of well-sized files. Each file may require metadata lookup, open and close operations, and task scheduling. The job may look busy, but each task is doing very little useful work. This creates high overhead and low efficiency. The symptoms are usually slow reads, long startup time, many tiny tasks, and poor throughput. What should you check? Look at the number of files in the table, the average file size, and whether the table needs compaction. The goal is simple: fewer, larger files when possible. The second problem is bad partitioning. Partitions are how Spark divides work across executor. When partitions are balanced, Spark can process data in parallel. But when partitions are too large, too small, empty, or uneven, performance suffers. One executor may become overloaded while others stay almost idle, or Spark may create many tiny tasks that waste scheduling time. The symptoms include idle executors, one overloaded executor, long stage duration, and unstable performance. Check the partition column, the partition count, and whether the key has too many unique values. Good partitioning spreads the work more evenly across the cluster. The third problem is expensive shuffle. Shuffle happens when Spark needs to move data across the network so records with the same key can be processed together. This often happens with joins, group by operations, distinct, and repartition. Shuffle is powerful, but it is expensive because it uses network traffic, disk input and output, and creates new stage boundaries. In the Spark UI, you may see long stage times, high shuffle read, high shuffle write, task delays, or even spill. To investigate, ask which operation triggered the shuffle. Was it a join, a group by, or a distinct? Can we filter earlier, reduce columns, or aggregate before moving data? Wide transformations often trigger shuffle, so treat them carefully. The fourth problem is data skew. Data skew happens when the data is not distributed evenly. Maybe one customer, one country, one date, or one key has much more data than the others. Spark may finish most tasks quickly, but one task keeps running because it received a huge amount of data. That task becomes the straggler, and the whole stage waits for it. The symptoms are clear. One task runs much longer, executor usage looks unbalanced, joins or aggregations become slow, and the stage looks almost finished but does not complete. Check key distribution, task duration imbalance, and skew indicators in Spark UI. Balanced data means balanced work. The fifth problem is slow joins. Joins are common in data engineering, but they can become very expensive when the data is large, poorly filtered, or joined using bad keys. A broadcast join can be fast when one table is small enough to send to the executor, but a shuffle join can be much slower because Spark needs to move large amounts of data across the cluster. Symptoms include long join stages, high shuffle cost, skewed join keys, and unexpected row explosion. Check the join type, table sizes, join keys, filters, and whether a broadcast join is possible. The best join is often the one that moves less data. The sixth problem is disk spill. Spark prefers to process data in memory because memory is fast. But when memory is not enough, Spark spills data to disk. This allows the job to continue, but it slows everything down because disk is much slower than memory. Spill is often connected to heavy shuffle, large joins, big aggregations, or poor partition sizing. In Spark UI, check memory spill, disk spill, executor pressure, and long-running stages. If spill is high, ask yourself, can I reduce the data earlier, improve partitions, optimize joins, or use a better cluster size? Spill is a warning sign, not just a number. The seventh problem is wrong cluster configuration. Even good code can run slowly on the wrong cluster. If the cluster is too small, Spark may suffer from memory pressure, queuing, and slow execution. But a bigger cluster is not always better. An over-provisioned cluster may cost more without improving performance. The goal is to match the cluster to the workload. Check worker count, CPU, memory, autoscaling, worker type, and whether the job should use a job cluster or an all-purpose cluster. Performance tuning is not only about code, it is also about infrastructure. When your Databricks job is slow, open Spark UI and start with the slowest stage. Do not guess. First, identify which stage has the highest duration. Then check task imbalance. If one task runs much longer than the others, you may have data skew. Next, review shuffle read and shuffle write. High shuffle usually means Spark is moving a lot of data. Then check spill metrics, join heavy stages, and executor utilization. The mindset is simple. Find the slowest stage, look for imbalance, measure data movement, and reduce waste before scaling. Let us recap. A slow Databricks job usually comes from one or more of these 7 problems: small files, bad partitioning, shuffle, skew, slow joins, disk spill, and wrong cluster configuration. This video is the umbrella view. Next, we can go deeper into Spark architecture, Spark UI, shuffle internals, and delta optimization. Learn the pain first, then master the fix.